All right, before we move on to lessons 4.4 and 4.5, we're going to look at the homework from that was assigned on lesson 4.3, proving lines parallel. So we're going to go ahead and work through the entire thing, even though we did half of them together. So number 1 says that 7 is congruent to 3. So let's look at those angles. So we've got 7 here and 3 here. And if we look at those are alternate interior angles. Right, for alternate interior angles to prove lines parallel, they have to be congruent, and that is exactly what this says, that these two are congruent. So yes, those lines would be parallel by the alternate interior angles theorem. On number 2, it says we've got angles 3 and angles 1. Right, so those are corresponding angles. In order for the corresponding angles to prove lines parallel, they would need to be congruent. So what we need to do on this one is we plug in 8 to both expressions, and we figure out what value that gives us for each of them. So when we plug in 8 to measure of angle 3, we end up getting 142 degrees. And we plug it into angle 1, we get 142 degrees as well. So since they are both equal, the angles or the lines are both parallel because of the corresponding angles theorem. On number 3, we're looking at angles 7 and 6. So angles 7 and 6, they're both on the inside, but they're on the same side of that transversal, so that would mean that they are same side interior angles. In order for same side interior angles to prove lines parallel, they have to be supplementary. They're the only one of these 4 that we've talked about that have to be supplementary. Right, so what we have to do is see if those would be supplementary. Now, what it does say is that angle 7 is congruent to angle 6. Right? So in every situation except for 1, these angles would not be supplementary. The only time that they would be supplementary is if both angles were 90 degrees. Now, the thing with this is we can't necessarily go by the picture and say that they aren't 90 degrees because they don't look like it, because again, it might be different and the picture might not be drawn to scale. So the correct answer for this one is no, unless the angles measures are 90 degrees. If either of the angles measures 90 degrees, since they would be congruent, the other one would be 90 degrees as well, and 90 plus 90 is 180. On number 4, what we're looking at this one, we're going to plug in 14 to both of these equations. When we plug in 14 to both of them, we get that measure of angle 2 is 73 degrees, and measure of angle 3 is 107 degrees. So let's look at where those angles lie on this. Angle 2 is here, angle 3 is here. Those are also same side interior angles. Right? So same side interior angles have to add up to 180 for the lines to be parallel. 73 plus 107 is 180 degrees. So yes, those would prove that the lines are parallel by the same side interior angles theorem. Looking at number 5 now. All right, number 5, let's go ahead and look at what angles we have. We've got angle 8 and angle 4. Alright, both of those are on the outside. They're not in between the two lines, so they're exterior. They're on opposite sides of the transversal, so they're alternate exterior angles. In order for alternate exterior angles to prove lines parallel, they have to be congruent. So what we're going to do is we're going to plug in 9 to both of these expressions. When we plug in 9 to measure of angle 8, we end up getting 53 degrees. When we plug into measure of angle 4, we get 48 degrees. Alright, 53 is not the same as 48, so therefore this proves that this is not parallel lines. Alright, let's look at number 6, where now we're going to compare angles 5 and 7. So angles 5 and 7 are in the same location at both intersections, which would make them corresponding angles. Right? Corresponding angles need to be congruent. Since it says angle 5 is congruent to angle 7, yes, these lines will be parallel by the corresponding angles theorem. Number 7, we're looking at angles 1 and 5. So angle 1 and 5, they're both on the outside, so they're exterior. They're on opposite sides of the transversal, so they're alternate exterior. Alternate exterior need to be congruent, so it gives us that those two angles are congruent. Therefore, yes, these two are congruent by the alternate exterior angles theorem. And the last one on this page, we've got angle, or number 8, where it says measure of angle 6 is x plus 10, and measure of angle 2 is x plus 15. So if we look at where those are located, they are alternate interior angles theorem, or they would be alternate interior angles. Okay, so for them to be the lines to be parallel, those would have to be equal to each other. The problem with this one is they don't give us exact value to plug in, but we can still compare to see if they would end up being equal to each other. So if these would be equal to each other, we'd end up having x plus 10 equal to x plus 15. So let's solve for x. Well, let's get rid of the x here. Whatever I do to one side, I do to the other. Alright, so I'm getting rid of the x. Right? So now I've got 10 and 15. Let's move this 10 to the other side by subtracting 10. Right? The x's cancel out. Alright, so that would be 0. The 10's cancel out, so that's still 0. So I'm pulling down my 0 because I need to keep something on the left side of the equal sign. Alright, and then the x's cancel out. Well, now we don't have an x. Right? 15 minus 10 gives us 5. Alright, so now we get this answer here that's weird because we don't have an x, but now it says 0 equals to 5. Alright, in the real world, 0 cannot equal to 5 because those are two completely different numbers. So since these do not equal each other, there's no possible way that these two angles could be congruent, so therefore the angles are not parallel, the lines are not parallel. Alright, now let's look at lesson 4.4 on perpendicular lines. So a perpendicular lines means that when they intersect, they form right angles. Right, so we'll notice whenever we're talking about perpendicular lines, you're often going to see this little upside down capital T. That symbol means is perpendicular to. So if we have this situation here where it says A is perpendicular to B, that means all 4 angles where they meet are 90 degrees. We're going to use that same thing for problems 1, 2, and 3, where it then says A is perpendicular to B. So if A is perpendicular to B, that means we have this 90 degree angle, which they actually already marked for us. And we have a couple other ones that we can work through. So first thing it wants us to know is what is the value of Z. So looking at this, if we know that this is 90 degrees, all 4 of these angles together are 90 degrees. So I'm not talking about x and y by themselves, but I'm talking about this one in general. So if we're just looking at Z itself, because it's just one of those corners, we know that it's 90 degrees. Alright, for the next one, what we're going to have to do is we're going to look at this and we're going to say if y equals to 50, what's the value of x? So what we're going to do is we're going to replace y with 50. Now we're going to look at x. So if we look at this entire corner, the entire corner has to equal 90. Okay? So the way that we can find the missing information on this, we're going to do 90 minus 50, giving us 40. Okay, so x is 40. Okay. And actually on this one, whenever you are looking at a value, just the variable, you do not need to put the degree sign. You put the degree sign whenever you have like measure of angle x would then be 90 degrees. If you see those little m for the measure, then that means you put the degree sign. Okay. So besides that, now we're going to go ahead and look at the next value. Alright, so this one ends up giving us a different value for this one here. Alright, just real quick, we're going to ignore that and we're going to go back to trying to find the value of w without doing this at first. Now, this is just hypothetical. Do not copy any of this down. But if we were just knowing the information that we have, again, we know x is 40. If we wanted to find w based off the information from number 2, right, the easiest way that we do this is the x is across from the w, making them vertical angles. So in this situation, if we use the original problem from number 2, w is 40. However, this is a different problem. So actually, all the information that we put from number 2, where we said that x was 40 and y was 50, that is all gone. So what we actually need to do is now we need to look at this plugging in v as 60. So now we're just looking at v as 60, right? The other information from before is gone, but we still know that this is a right angle for the entire thing. So if this part's 60, what we're going to do is instead of doing 90 minus 50, we're going to change this to 90 minus 60. All right, 90 minus 60 gives us 30. So angle W, or the value of W, is 30. That then takes us to the next section, where we're now talking about the perpendicular bisector of a segment forms two right angles. It divides a segment into two equal lengths. All right, in this situation, we've got WZ is the perpendicular bisector of XY. So notice, WZ is the bisector. Right? So that's the one that is cutting something in half. Right? So WZ is this section here. It comes in and cuts XY in half. So notice that they have the markings that show that these are equal to each other. Now, WZ is not cut in half. It just cuts the other part in half. The other thing about it is the perpendicular part means that where it meets is 90 degrees. So we've got the 90 degrees here, and technically all four parts here are 90 degrees. Now, what it does not tell you in this situation is what you can use something on a perpendicular bisector. If you know any point on a perpendicular bisector, let's call this point A, right? It has to be the same distance to the endpoints of the line that you are bisecting. So notice these two parts would end up being the same. Okay. Now, the reason for this goes back to Pythagorean Theorem. A squared plus b squared equals c squared. So say we ignore that we have these two parts being exactly the same already. Right? We just know this line here. Right? So if I want to figure out this, I'm going to go ahead and call the length xz a. Right? So if xz is a, since yz is the same, that is also a. Right? Now, the other part of Pythagorean Theorem, we've got the a part, now we want the b, so that would be the other leg. Right? So the leg on these two right triangles is this one here. So notice, these two end up having matching parts. So the a would be the same for both these triangles. The b would be the same for both these triangles. That means that the c, the hypotenuse, has to be the same as well. So both of these would have to be c, meaning that that is a quick little proof showing why this ends up working. But basically on this is if you have any point that's on a perpendicular bisector, the points to the middle line, no matter where they're at, is the same distance on both sides. So we're going to apply that to this next problem here. So it says AC is the perpendicular bisector of BC. So AC is the one doing the bisecting. So AC is this line here. What it does is it cuts BD in half. So this section's the same as this section, and all of these are 90 degrees. It wants to first know what's the measure of angle ABC, or BEC. So BEC, if I follow with my finger, right, B comes down to E, goes to C, meaning that this is the angle we're looking for. Again, since we know that it's a 90 degree angle, the measure of this angle, since that's a little m, what that little m stands for, we'll put 90 degrees. Now the next part then says that BD is 8. It wants you to find DE. So BD, the entire length, is 8. Remember, this is cut in half. So what we're going to do is we're going to do 8 divided by 2, giving you 4. So this side is 4 and this side is 4, and therefore DE is also going to be 4. Alright, we're going to use this to answer some of the problems on the homework. Whatever is not answered on this will be left for you to do later. So we're skipping this for now. Then we're going to come back to this page, and we're going to go ahead and I'm going to leave 1 and 2 for you. Let's go ahead and look at the actual proof. So with the proof, what we're doing on this one is we're given that M is perpendicular to N. So M is perpendicular to N, meaning that all 4 of these angles are 90 degrees. So we can mark it on our pictures to show it. Right. And then what we're trying to prove is that angles 1 and 2 are a linear pair of congruent angles. So we want to know that they add up to 180 degrees and form are congruent to each other. Right. We basically have already shown that we do this, because if we know that it's perpendicular, angle 1 is 90, angle 2 is 90. They both make a linear pair, and they both are equal to each other. Right. So again, with a proof, you start off with what you're given. So the thing that we were given is M is perpendicular to N. So let's go ahead and copy that down. M perpendicular to N. And again, the reason is given. Right. We're going to skip the other parts for now, and what we're trying to prove is always the last step. Now, you do not put given for the reason of your last step, or prove for the reason of your last step. The only time you can put given is that first line, anything that you are given on this. So what we're going to have for the final step is that angle 1 and angle 2 are a linear, and I'm going to abbreviate that, pair of congruent angles. Okay, and that's going to be our final step, but we have 3 other things that come before that. Okay, so with this one, now we're going to look at this, and it says that number 2, that it's a definition of perpendicular. Alright, so notice that angles 1 and 2 are angles that are formed by M and N. So if we're looking at this, okay, since they're formed by M and N, since we know that M and M now have to form right angles, we're going to end up saying that measure of angle 1 equals 90 degrees, and measure of angle 2 equals 90 degrees. Again, that's just because we know that they were perpendicular. Okay, so now that we have that both these ones are equal to 90 degrees, we then can say that they are congruent to each other. Again, switching between equals and congruent, you got the numbers are equal, the figures are congruent. If you switch it, it's the definition of congruent. Right. And then the next step they have is just kind of adding angle 1 plus angle 2, giving them 180 degrees. It's addition property of equality. They added 90 plus 90, working through the same way. Okay. And then that then shows, because of steps 3, where they know that they're congruent and that they are a linear pair because they add up to 180 degrees, then we know that's definition of a linear pair. Now let's look quickly at number 4. It says the Four Corners National Monument is at the intersection of the borders of Arizona, Colorado, New Mexico, and Utah. It is called the Four Corners because the intersecting borders are perpendicular. If you were to lie down on the intersection, you could be in 4 states at the same time. The only place in the United States where this is possible. So that's the four corners. The figure shows the Colorado / Utah border extending north in a straight line until it intersects with the Wyoming border at a right angle. All right, so we're going to explain why the Colorado-Wyoming border must be parallel to the Colorado-New Mexico border. Okay, so what we're looking for is we're trying to figure out how this border is parallel to this border. So this should be fairly familiar because we just kind of talked about how lines were parallel. So notice we've got this 90-degree angle here, we've got this 90-degree angle here. All right, when you're looking at that, those two angles are on the inside of two lines and on the same side of a transversal that goes through both of them. Now granted, this isn't going all the way through, but you could extend it and it would. All right, now both angles are 90 degrees. Those are same side interior angles. Okay, so same side interior angles, to prove lines are parallel, have to be supplementary. If we have 90 plus 90, that is 180 degrees, so proves that these are supplementary. All right, so the reason why this one would be is the borders form same side interior angles that are supplementary. And that's honestly all you need. So that proves that those end up being parallel. Okay, so you've got numbers 1 and 2 to look at for homework. And now we're going to go quickly back to 4, 5, where now we're looking at equations of parallel and perpendicular lines. So this again should be a refresher from algebra. Parallel lines have equal slopes. All right. So again, if you recall slopes were normally referred to as rise over run, or however many you go up and down over how much you go left and right. You also saw it in slope-intercept form, where it was y equals mx plus b, where m is the slope. All right, so notice in the next line here they have the lines negative 3x plus 4 and negative 3x minus 2 are parallel. The reason being is we both have the slopes of negative 3. So the other thing about them being parallel is they have to have different y-intercepts. If the y-intercept's the same, they would actually be the same line, so that would be something called coinciding. Right? So in order for you to actually prove lines parallel, they have to have different different y-intercepts but the same slope. So now what they end up doing here is they have this problem that they're saying use point slope form. We're not going to use point slope form. Instead, we're going to do it a little differently. So I'm going to actually write this one to the side here, and we're going to work through a little different than the ones that they have. So we want a line that's parallel to 2x minus 3 that goes to the point 2, 8. So what we're going to do instead of what they have, right, because it needs to be parallel, slope's going to be 2. Right, it gives us a point. So in this ordered pair, the first one's your x, the second one's your y. Right, so if I actually go to my y equals mx plus b, right, I'm going to plug in the m, the x, and the y, and the only thing I'll have left is the b. So I can easily solve for b doing this, and then I want to get back into y equals mx plus b form, so what I'm going to do is then rewrite it without x and y put in, or the 2 and the 8 for the x and y. So let's look at exactly how this is referred. So y equals mx plus b. In this equation, or this part, we've got y being 8. So that's what I'm going to do. I'm going to put 8 equals to m, which is 2, times x, which is 2, plus b. So now I've got three numbers and a variable. So let's work with the numbers. 2 times 2 is 4 plus b, and that 8 just comes down because I haven't done anything with it. Alright, I want to get b by itself, so I'm going to subtract 4. And now 8 minus 4 gives us 4, and then we've got 4 equals to b. So now we've got a solution for b, and we already had a solution for m. Since we now have both of those, we just basically go back to y equals mx plus b, and we've now got y equals to 2x plus 4. Now, since it's plus 4 because this is a positive 4, if it was a negative 4, it'd be minus 4. Anyway, that would be the equation of the line that goes through the point 2, 8 that is parallel to y equals 2x minus 3. So now let's look at the same thing with number 1 at once. What's the slope of a line parallel to y equals negative 5x plus 13? So when we're looking at this, the slope of the original one is negative 5. So if it's parallel, it should have the same slope. So we're going to do negative 5 as well. And then number 2, it says we want an equation of a line parallel to y equals 5x plus 3 that passes through 3, 3. Right, so looking at the equation originally, we've got the slope being 5. So m equals to 5. Right? And we want to do it in y equals mx plus b again. So y equals mx plus b. So we're using the points 3, 3. So the y is the y value here. So we're going to put 3 equals to 5 times the x value, which is 3, plus b. So 5 times 3 is 15, plus b. Alright, pull the 3 down. This 15's got to go away, so we're going to subtract 15. And now we're left with negative 12 equals to b. So we've got our m, we've got our b. We go back and replace the x and y with how they were. Y equals to 5x minus 12. And that's your answer for the line that would be parallel to y equals 5x plus 3 and going through the point 3, 3. Alright, so the next part has perpendicular lines have the slope that multiply to equal negative 1. So this is a kind of complex. It can be confusing on exactly what that means, but the easiest way to look at this, instead of saying they multiply equal negative 1, is to say that they are opposite reciprocals. Right? What an opposite reciprocal means is that you change the sign and you flip the fraction. Right, so notice they end up having this first one where they give us the equation that we've got y equals negative 3x plus 1 is perpendicular to y equals 1/3 x. So let's look at those and see how that works. So the first one is negative 3. Right? So negative 3 by itself it's fine. It's understood that it's over 1. So to change the sign for the opposite part, the negative becomes a positive. Right? And we're going to end up flipping this. So 3 over 1 becomes 1 over 3. So notice how those ends up working. Now, we also can do it with different numbers. You don't have to have that one. Let's say we do 5/2. So this is a positive 5/2. The negative reciprocal or opposite reciprocal, since it's already positive, now becomes a negative. The 2 goes to the top and the 5 goes to the bottom. So there's your opposite reciprocal there. we're going to do one more. And let's go ahead and say we've got this one, and we're going to say that we've got negative 3/4. Alright, so negative 3/4. Change the sign to a positive. Alright, so positive, and then the 4 goes on top, the 3 goes on bottom. So 4/3 is your opposite reciprocal. Now the only other one that you might get tricked up with is whenever we end up getting an equation where the slope is 0. So if you have 0, it's not necessarily opposite reciprocal, but the 0, whenever you do it, the one that's perpendicular has a slope that's undefined. Alright, and it works vice versa. If the slope's undefined, then you end up having the perpendicular one being 0. Now what this ends up normally equating to is, now for the slope being this, it's going to be y equals to a number, and whenever it's undefined, it's x equals to a number. Right. So if you see any equation and you want it being perpendicular and it says y equals to 3, then you're going to have x equals to something for it to be perpendicular, or vice versa. Right. So again, they say use point slope form. We're going to ignore point slope form because I believe the way that I taught works a lot easier. Alright, so number 3, it says, what is the slope of a line perpendicular to negative 2/3? So looking at this, we got the original slope being negative 2/3, so our new slope has to adjust that. So since it was already negative, it becomes positive. The 3 goes to the top, the 2 goes to the bottom, so we get 3/2 for our new slope. The number 4 says, what is an equation that is perpendicular to the line y equals negative 1/2 x plus 5 that it passes through 2, 2. So again, look at the original slope, negative 1/2. We need to adjust that. So negative 1/2, we're going to end up changing that one. And now the new slope that we're going to use, the negative becomes a positive, the 2 goes on top, the 1 goes on the bottom. Since the 1 is basically not important, if you divide 2 by 1 it gives you 2, we can just leave it as that. So this one, I don't like the numbers that they include on this, but we're still going to use the numbers that they included. Right. This is our x, this is our y. So we're going to the equation y equals mx plus b. We replace y with the 2 for the y value, the m with the 2 that we got for the slope, and the x with the 2 for the x, and then we're going to say plus b. So 2 times 2 is 4, plus b on the right, still equals to 2. Subtract 4 from both sides, and now we've got negative 2 equals to b. So there's our y-intercept. Go back, taking out x and y, so y equals to 2x minus 2 for our answer. Alright, we're going to look at some problems on the homework, and again, whatever is not covered is assigned to you for homework. So let's look at number 2. So on number 2, what we're going to do here is we need to find the slope of this. So they give a specific point that we're working with, and we're going to work through those ones. So we've got this point here, and we're going to go down to here. So we've got to figure out rise and run. So I'm just going to connect this with a right triangle and figure out like the lengths. So I'm going to go right here above it, and then I'm going to count up. So from negative 2 to positive 1 is a distance of 3, and then going from 9 to 3 goes down 6. Alright, so the thing with this one is we got to remember up and down as well. if you notice that it's going down when you're going to the right, it's going to be negative. So you should double check that. If it's going up when you're moving to the right, then it's going to be positive. Right? So what we're going to look at this is rise is up and down. So we've got this 6. So it rises 6. Technically we're going down 6 with how I did it, but you could switch these around. So this one could be negative or positive, just depending on how you end up working it. Okay. So I went down 6. The run, I went right 3, so that's a positive 3. Now, let me change the colors and look at this differently. If I went instead this direction first, and then this direction, that still is the same way. But if I wanted to go in the opposite direction, let's say I start at the bottom and I go left 3 and then up 6, my answer would change a little bit. I would just have this as a positive 6 and then this as a negative 3. Either of these ones work depending on how you work the problem. But when you're going to do it either way, rise over run, if I start off with this one, if I do 6 over negative 3, right, let's stay with that color, 6 over a negative 3, we've got a positive and negative, so our answer is going to be negative. 6 divided by 3 is 2, so negative 2. Now if I use the original one that I did, which was negative 6 and 3, then that would be negative 6 over 3, right? Negative and positive still gives us a negative, and then 6 over 3 is still 2. So either way, you get the same answer. All right, so it doesn't matter. But again, remember, it's going to be a negative slope because we're going down when we're going to the right. So let's look at number 4, where now we've got this line that we want to be parallel to this that goes to the point 2, 7. So let's look at this one. And we know that the slope that we're going to look for is 9. So M is 9. And it goes through 2, 7. So I'm going to replace this. Again, I'm going to just go ahead and write this off to the side. Y equals mx plus b. But I'm not going to rewrite this on every single problem. If it helps you to do that, do it. But I'm trying to save a little bit of space with this, and I'm working through it. So I'm going to replace the y with 7. So 7 equals to 9 times 2 plus b. 9 times 2 is 18 plus b. So 7 equals to 18 plus b. Subtract 18. 7 minus 18. Right? So again, this is a nice trick to have this. If you're subtracting a bigger number, or if you're doing something where you're either adding or subtracting and they're different signs, the rule is you subtract and keep the sign of the bigger one. If they're the same sign, you just add and keep the signs. So again, if it was 2 negatives, add, keep a negative. If it's 2 positive, add, keep a positive. If there was 1 positive, 1 negative, you subtract, and whichever one's a bigger number, you keep that sign. So on this one, we're going to do 18 minus 7, which is 11, but we're going to keep the negative because 18 is bigger than 7. So negative 11 equals to b. So now we've got our b value. We go back to just writing our equation. Y equals to 9x minus 11. And there's our answer. We're going to do number 6 the same way. All right, so the slope is 2/3. We're going to keep 2/3. Right, and now we're going to plug in the values. So 6 for our y equals to 2/3 times negative 3 plus b. Alright, so if we're taking a fraction and multiplying by this, right, if it's fraction times a whole number, don't confuse yourself. Don't put anything over 1. If you want to do that in top times top, bottom times bottom, that's fine. But if it's just times a whole number, all you really got to do is 2 times negative 3. Right? 2 times negative 3 is negative 6. Then divide by 3. So negative 6 divided by 3 gives us negative 2 plus b. equals to 6. Now we got to get rid of that negative 2, so we're adding 2 to both sides. So 6 plus 2 is 8. 8 equals to b. Our answer is now y equals to 2/3 x plus 8. Now number 8, we're moving to being perpendicular. So now we've got to change this one around. The original slope is 1/4. So we need our new slope, which will be the opposite reciprocal. So since the original one was positive, this one's going to be negative. So negative. Right. 1/4 flips over. The 4 on top, 1 on bottom. The 1 goes away. We get -4. Alright, we got to go through the 0.41. So 1 equals to -4x, which x is 4. So -4 times 4 plus b. -4 times 4 gives us -16 plus b. And now it's 1 equals to -16 plus b. Add 16 to both sides. Okay. And 17 equals to b. Alright, we've got our b, we've got our slope. Y equals to -4x plus 17. And there's your answer. Number 10, the original one is -6x minus 9. We want it to be perpendicular, so our new slope, the -6, would be -6/1, becomes positive, and then the 6 goes to the bottom, 1 goes to the top, so positive 1/6. Alright, we're going to the equation now. So the y value is 10. 10 equals to 1/6 times 6 plus b. 1/6 times 6. 1 times 6 is 6. 6 divided by 6 is 1. So we got 1 plus b equals to 10. Subtract 1. And then we get 9 equals to b. So final answer, y equals to 1/6 x plus 9. Alright, so that leaves the odds for homework. Your next class period will be a test over chapter 4, which includes alternate interior angles, vertical angles, corresponding angles, linear pair, same side interior angles, alternate exterior angles, writing equations of lines that are parallel or perpendicular, perpendicular lines, including that one where we have the perpendicular bisector. Anything that's in this note stuff that we've had for 4.1 through 4.5 will be on the test. Study those and you will be ready. There is not a review specifically for this test. Okay. So make sure you are ready for the test. It is only over this chapter 4 information.